Did you know you're looking at the second most used substance in the world? And can you guess what it is? It's concrete, and we use about 30 billion tons of it each year, and the production of it accounts for about 8% of our CO2 emissions. Which is why Dr. Espinosa Ortiz in the Biological Engineering Department is leading an effort to develop a sustainable alternative to concrete.
We are trying to use microorganisms like fungi and bacteria to create cement, which is one of the biggest components of concrete.
This actually happens in nature where fungi and bacteria can produce minerals, and in this particular case, the researchers are producing calcium carbonate, which is essentially limestone.
So we're just kind of taking that natural process that's happening, but just engineering it or directing it a little bit more to get it to grow off the exact materials we're looking at.
So Bradley is using hemp fibers as a rebar of sorts, and then growing a fungus on those fibers, and then he introduces a bacteria to help calcify and solidify the whole thing into this.
And we're working pretty small scale here, but we've fine-tuned the method for this production, and so now the idea is to scale this up, make larger bricks, and then strength test those to kind of see what these added benefits of mineralization are.
Simultaneously, another researcher, Alondra, is working to use fungus to recover minerals from construction waste.
So we can do a bunch of processes using fungus and bacteria to break down this concrete and recover minerals, especially calcium and silicone.
Essentially, there's a fungus out there that will secrete acids, and they'll use those to break down the concrete into a solution, and then they can extract the minerals from that solution later on.
These are the kind of processes that we need to establish now because they're going to be essential in the future.
And this work really is future focused because as our cities continue to grow, we're going to need sustainable options to help us build.
The ultimate goal is to try to make them as strong as possible to potentially one day replace the actual concrete.